is not commonly used in the practice. So this is the perfect time for us to revisit this topic, which is about the direct gold. As we know, we are not using this in our practice, right? But it's it's considered to be the gold standard among the restorative materials. So when we say gold standard, the new materials, they are also being compared with the characteristic of a gold restoration. So until now, we should always appreciate and understand the gold restorations. Kasi nga, we will never understand the future and the current materials unless we look back and we understand the behavior and the characteristic of gold restorations. Okay, so for the topic, it's all about direct gold restorations. So when we say direct gold restoration, this is um, uh, defined as the kind of direct gold. It's a direct restorative technique wherein it involves the use of gold restorative materials that is manufactured and it is being placed directly into the prepared cavity. So on the same appointment, the direct gold restoration, this is provided. It is compacted into the prepared cavity. So that's the direct gold restoration. So the gold, this is one of the earliest material that's available in dentistry. As a matter of fact, as early as 1483, it has been reported in literature that Giovanni di Arcoli, he recommended the use of gold leaf fillings for resto. And then Philip Pfaff, he is the dentist of Frederick the Great of Prussia. No? They use gold to cap the pulp for direct pulp capping. They use the gold. Okay, and then in 1795, it has been reported that Robert Waffendale, he introduced gold foil for resto in America, in the US. But in 1803, Edward Hudson, he used gold foil to fill root canal as a direct filling for root canal. And in 1838, Dr. Merritt of Pittsburgh, he introduced the technique of using hand mallet for placing the restoration. So gold leaf was used as a restorative material and it became popular in the US during the 19th century. And Marcus Ball from Connecticut, he began producing beaten gold for dental application in 1812 because they used many kinds of restorative materials before. So the gold, it has not been manufactured in a standard manner. So there are many ways of manufacturing gold for restoration. But in 1812, it was introduced, the beaten gold, the hammered gold for restoration. And in 1853, they started to use sponge gold, another kind of preparation for restorative gold. And then they started to use cohesive or adhesive gold in 1855 in the US. So we will understand the different kinds of gold later because that's our next topic. We will see the different kinds of gold preparation. So in 1964, powdered gold was used. And in 1980, easy gold was introduced. And in 1989, a granular type of gold was introduced in the market. So as you can see, it all started even during prehistoric time. No, they used gold. Okay, I think early men they have used gold, but you know what? Gold is still regarded as the best restorative material until now. The only reason why we're not using gold is because of the scarcity. Because of the scarcity, because gold is not only in dentistry, right? It has high demand in other use, like in jewelries and everything. That's why the use of gold is very limited nowadays because of the cost due to the increasing demand. But still, gold is considered to be the most biocompatible. It's one of the most serviceable restorative material that we have. It can even last a lifetime when prepared properly. It's the only restorative materials that can promise to last a lifetime. But then again, because of the cost, we are not doing the gold restoration anymore. And because of the technology, because nowadays, di ba, we have new materials like composite, also we have compomer, because of the newer materials that can give us conservative approach in managing dental caries. So therefore, we are more into minimum intervention dentistry. So that's why gold has been in the history already, but still we can use gold. So what's the secret behind the longevity of the gold? Why can gold promise us a lifetime? It's because it's the most durable there is. Okay? The longevity of gold, again, it can last a lifetime because when properly manipulated, gold can provide us excellent marginal integrity, wherein the sealing ability is very high. Gold, when placed correctly, it can have good adaptation to the walls of your cavity preparation. So therefore, secondary caries is not so evident. And to add more, you know the coefficient of thermal expansion of gold? It is very close to the tooth. So you don't see much of those micro leakage, okay, regarding the use of gold. So that's why the excellent marginal integrity, it can make the gold last a lifetime. Also, another secret for the longevity of the gold, it offers super biocompatibility. It's the friendliest to the human body. I know you'll agree with me. Some chefs would even, di ba, some chefs, they would even place gold in foods because gold, it can never harm human body. Okay? So it is not known to cause any harm to the human body. And also, the human body cannot destroy gold. Gold is a noble metal. We know what we mean by the noble metal, right? So by gold itself, it does not tarnish, it does not corrode. Just like when you have the jewelry made up of gold, you don't see it being destroyed by tarnish or corrosion, right? And also, it does not get dissolved into the oral cavity by the saliva. So these are the two main reasons why gold is considered to be the most durable restorative material there is on earth. Okay, going back to the excellent marginal integrity, aside from the linear coefficient of thermal expansion that is close to that of the tooth, another reason why we have excellent marginal adaptation is because gold is the most malleable metal there is on earth. Also, it's the most ductile metal on earth. So we will be defining them later, no? And also another one is, why is gold ideal for direct restoration? You don't need to heat the gold. So I know gold is a metal, right? So gold can be used directly into the prepared cavity. It's because gold, it can be welded under room temperature. So you can combine increments of gold without heating it, as long as the surface of the gold is clean. And another one, the gold must be 24 karat, pure gold. Okay? So pure 24 karat gold, if the surface is clean, pieces of gold, let's say for example, if you want to join two pieces of gold together, like when you're doing condensation, ano, so for restoration, they can combine together. So gold increments can combine to one another, provided that it's pure gold without impurities, as long as the surfaces are clean. So these are the reasons why it's an ideal direct restorative material. So let's go back to ductility and malleability. We mentioned that gold, it's the most ductile, it's the most malleable metal. So what is ductility? Ductility, this is defined as the ability of any solid material to deform under tensile stress. So in short, it's the ability of the material to be stretched without being fractured. So the gold, it can be turned into very thin wire. You can stretch out the gold into very, very thin wire without fracture, without breaking. So it's the most malleable, ductile. Ductility is the ability to become stress, application of tensile stress without fracture. So you can draw the gold to become very thin wire without fracture. It's the most ductile. Now, gold is also considered to be the most malleable metal because you can hammer, you can hammer the gold to become very, very thin sheet, again, without fracturing. Okay? So you can turn the gold into very, very thin sheet of gold without breaking. So because of that malleability and ductility, imagine that. So good is the adaptation on the walls of your tooth or the cavity preparation if gold is too malleable and ductile. So because of the malleability and ductility of the gold, there is good adaptation onto the tooth preparation. So these are the secrets of the gold, why it is with excellent marginal adaptation. And then this is what I've explained about, no? Kasi diba, it's very difficult for you to do the restoration kasi how are you going to shape the restoration? Confirming to the cavity preparation. Especially if it is metal, on earth, diba, metal is considered to be solid. So the challenge is, how are you going to turn the solid into the same shape as the cavity preparation? So for amalgam, when you turn the amalgam alloy into powder and then mix it with the liquid mercury, it now becomes plastic. It can now be molded to become a restoration. So for the gold, you don't need to combine it with the mercury. You don't need to heat this. Gold being malleable, it can be condensed into the prepared cavity. So like what you can see here, this is one increment of gold. You can combine another increment of gold. They will combine together. So there is possibility of joining pieces of gold together. That's what we call welding, diba? When you say welding, that means joining the pieces of metal together. So for the gold, you don't need to heat it. So cold welding, this is called cold welding or contact welding is possible with gold without heating it. It's because gold, being malleable and ductile and being able to be cold welded, by just means of condensation, the increments of gold can combine together. So the only requirement is for pieces of gold to combine together, the surface must be pure or clean without contaminants. So there are ways by which we can clean or maintain the purity of the surface of the gold so that when you use it for direct restoration, they can combine. They can possibly become cold welded. Okay, so later we will be discussing that. So for now, let's discuss the different types of gold for direct filling. So for direct filling, we have three kinds of gold. We can use gold foil, powdered gold, or granulated gold. So for gold foil, there are many kinds of gold foil or many kinds of preparation. It can be on sheets like this, or you can turn it into something like ropes, rope shape. You can roll to make it something like rope, or you can turn them into something like cylinders in shape, or gold foil can also be laminated or platinized. So we will be discussing this one by one. So let's start with the gold foil. Gold foil, in general, whatever the type is, all the gold foil, this is manufactured by beating the gold. When you say beating the gold, you are really to hammer the gold to become very, very thin sheets like this. So during the time that the dentists are still using gold foil, this is how they do it. You see that? Yeah. So they used to buy gold foil. Sometimes they use gold foil. So it comes in something like a booklet wherein the very, very thin sheets of gold, they are separated by these papers. So gold foil, this is manufactured by beating or hammering the gold. Or other than hammering or beating the gold, it can also be by rolling the gold until it becomes very thin sheets. So dentists, during the time that they're still using the gold foil, they can either use gold foil number 4 or gold foil number 2. What's the difference? The difference is the thickness. So usually if it's number 4 foil, it is considered to be 4 grams and the thickness will be 0.51. 4 grains to, 4 grains. So that the weight is 0.259 grams per sheet. And then, when it is number 2, it's 2 grains of gold, and the weight is 0.194 grams per sheet. And the thickness per sheet will be 0.38 microns. So it's very, very thin, really. Okay, so this is the gold foil. Now, the gold foil is also known as the fibrous gold. So gold foil is also called fibrous gold. So during manufacturing, by beating or hammering or rolling, no, the gold foil, this is available in 4 by 4-inch sheets. And this is being sold in books or in booklet, parang siyang booklet, wherein each of the gold pieces are separated by thin paper. So later, I will be discussing how are the dentists going to use this in restoration, because dentists would need to prepare this. It's not yet ready for restoration. Dentists would need to cut this, to roll this, so that they can use it for restoration. So later, I'll be showing you that. Just to continue, no, another preparation of gold foil. Gold foil can be rolled to become cylinder. So from sheet, using a tapestry needle, the needle for sewing. So using the tapestry needle, the gold foil will be rolled to become cylinders. So after rolling it to become cylinder, diba, it will be something like this, rolled cylinder. So the dentist would need to cut them into smaller bits, and this will be ready for condensation. Okay? So gold foil can be prepared into gold foil cylinder by just rolling it using a tapestry needle. Okay, so this is how it's done. You see that? So using the tapestry needle, it's being the gold is being rolled. The gold foil is being rolled to become cylindrical in shape, and then they're going to cut the cylinders into tiny bits. This is the one that's ready for compaction into the prepared cavity. So basically, it's only gold foil, just that it's being rolled to become cylinder. Okay? Yan. So other naman, except for the cylinder, no? So manufacturers will turn them into ropes. So coming from the hammered sheets, they would roll it, and then they would stretch it out to become something like ropes before they turn it into smaller bits. So that's what we call rope, gold rope. Okay? Then there will be a special type of gold foil which is called carbonized or corrugated. When you say carbonized or corrugated, this is the type that is being burned. You know how it all started? The use of corrugated or carbonized gold, it all started around this time, around 1871, because in 1871, there was a great Chicago fire wherein some clinics has been caught in fire. So during the time that the clinics were burning, gold that was kept by the dentist, they also burn. And then after the fire has stopped, they noticed the gold, they become shrivered. Para siyang, it became corrugated. And then when they started to observe this corrugated gold that accidentally became burned before, di ba? They noticed the corrugated gold foil, it is more cohesive than the plain ones. Meaning it's more pure. Cold welding is better when it's corrugated gold foil. So because of this, they now started, accidental is the discovery, di ba? They now started to manufacture corrugated or carbonized gold. So manufacturers, how do they manufacture corrugated or carbonized foil? So they would gather gold foil sheets, and then they would place thin sheet of paper, ordinary paper, between two gold foil sheets. And then they will ignite the paper. So when the paper become ignited, the paper will then burn out together with the gold. So after this, the gold will then become shriveled and it will assume corrugated appearance. Now, they have manufactured corrugated gold foil. So don't forget that corrugated gold foil, this is far better. Although it's accidentally discovered, but corrugated gold foil is more cohesive than the plain one. So in gold, when we say more cohesive, they can become cold welded better. So the joining of pieces of gold will be better if it is cohesive. Okay? Now, another type of gold foil is the laminated. When we say laminated, di ba, it has been sandwiched during preparation. So, how is laminated gold foil manufactured? So, the laminated gold foil, this is manufactured by the dentist. So, what the dentist can do is, the dentist will get the sheets of gold together. So sheet number one, and then another sheet of gold on top of the previous, and then the dentist would get another sheet. Let's say, for example, three or more sheets of gold. So the dentist, what will do is, um, the dentist will hammer them together. So it's like, di ba, being malleable. So the sheets of gold on top of one another, the dentist would start to hammer them until they become combined. The different sheets will become combined together. So what's the good thing about laminated gold foil? Why are they trying to combine the sheets of gold together? Because they say, no, each of the sheet of gold, they have different direction of grains. Example, the grains of gold for the sheet will be something like this, and then the grains of the other one will be on different direction. So because of the difference in the direction of the grains, that will give better strength to the restoration. So combining the sheets will give better physical characteristic for the gold. That is laminated gold foil. Again, who's going to do this laminated gold foil? This is done by the dentist using the ordinary gold foil. And then another type is the platinized gold foil. So it's called platinized gold foil because instead of just laminating sheets of gold, they will add a sheet of platinum. So gold, platinum at the middle, and then um, gold again. So gold, platinum, gold. And then they would sandwich the platinum and then they will hammer the sheets together until they have completely combined them. Okay, so will gold and platinum combine together? Yes, because the atoms will combine together by means of the cladding process. So during rolling, during hammering, through cladding process, there will be combination of the platinum and the gold. Okay? So why are they doing this platinized gold foil? What's the purpose of adding platinum? So platinum will increase the hardness and the wear resistance of the restoration. If it's pure gold kasi, have you seen the pure gold? Pure gold kasi is too soft. Pure 24 karat gold, that is what is used, di ba, for gold foil. It's kind of soft. So to increase the hardness of the restoration and to increase the wear resistance, particularly on the occlusion, so adding platinum to the sheets of gold, it will improve the physical properties. And don't worry, because platinum, it will never affect the cleanliness or the purity of the surface of the gold. Cold welding is still possible even if it's added, the platinum is added. So that's about the gold foil. Again, gold foil is called the fibrous gold. And then when you buy the gold foil can either be in cohesive or non-cohesive form. So what's the difference between cohesive and non-cohesive form? So the cohesive gold foil, this is manufactured wherein the manufacturer will make sure that the gold foil is free of surface contaminant. Meaning it's really pure without surface contaminant. Therefore, it's really cohesive. Cold welding is facilitated. Kaya lang, the problem is, if you're the dentist and then you chose cohesive, you have to be careful in storing the gold in your office, because when you store the gold and when you expose the gold to the environment, upon exposure to gases in the environment, the gases will contaminate the surface of the gold. So it can now affect the cohesiveness of the gold. Okay? Yan. Now, the non-cohesive gold naman, manufacturers, they would preferentially apply ammonia on the surface. So what is ammonia? Ammonia is a substance, right? So ammonia, this is applied to the gold so that the gold becomes non-cohesive at the start. Because ammonia, this is one way of protecting the gold. Kasi ammonia, when it is contaminating the surface of the gold, because it is intentionally applied, the gases, the deleterious gases, the destructive gases in the environment, it will never contaminate the gold because there is ammonia that covers and protect the surface. So you might be wondering, may ammonia. If there is ammonia, will that affect the cold welding of the gold later when you do the restoration? Yes, ammonia will affect it, but we have the procedure by which ammonia can be removed by the dentist before application. And that will be discussed later. Okay? So now let's see the preparation. So for the dentist, if you buy the gold foil, if you purchase the gold foil, again, the gold foil, it comes in very thin sheets, like 4x4. So this might be too large to be used for the cavity preparation, right? So the dentist would need to prepare it. The dentist would need to roll it to become cylinders or pellets before you can use it for restoration. So this is what the dentist would do to prepare it. So way ahead of time, once you decide to prepare the gold, this is what you will be doing. As a dentist, what you will be doing is to cut the section of the 4x4 into smaller sheets. Okay? So the dentist would mark the gold foil and cut it